Kia ora koutou. In this snippet PLD video, I wanted to explore multiplicative thinking and how that is fostered almost right from the very beginning of the scope and sequence before it is directly linked to multiplication and division in terms of operations. So I've just made a quick little slideshow that makes it possible to kind of share some of that thinking. So within the scope and sequence, dot talks play a major role. I call them dot talks. Some people call them math talks, visual images, whatever it is. So dot talks are about noticing. So from the beginning of the scope and sequence, you will have dot talks that look a little bit like this. There are also other visual images within the scope and sequence, but they require and use the same skills. Okay, so with a dot talk, at the beginning of the scope and sequence, it's about noticing, right? All the way through, it's about noticing, but they will be using different knowledge as they go through and progress. So at the beginning, it's about noticing. What do you notice? I'm looking for them to notice anything: the shape, the color, shapes inside that they see, even the background, the color of the background, that there's more than one. All of those things, we'll be noticing those. So that's what we're doing. We're using these images to notice. Okay. Some of the images within the scope and sequence at the beginning, some of my children will say, it looks like a train. That's cool. Nothing is off the table. Okay. So as we move through, we're starting to see, what can you see inside it? What do you notice? And children will start saying, I can notice a 4, I can see a 4. When we're using these dot talks, this is only flashed up on the screen for 2 to 3 seconds. So they're creating a visual memory of that, and they're recalling what they've seen inside. You are not expecting them to know the whole. So they're seeing the whole, but they're noticing the parts. So you'll have children who may say, I noticed 2 4s inside of there. I noticed some 3s inside of there. They'll come to the point where, after you've flashed it up a couple of times, I saw a 4, a 5, and a 2. You may get the counters out. They may recreate this for themselves so they can hold it, play it around, match the patterns. They may then represent it in a visual way that makes sense to them so that they can see the whole. But knowing the whole isn't the end game. You don't want, at the beginning, children are not going to be able to conceptually supervise that quickly that they'll notice the whole, because that is not the end game. What we're wanting to foster is for them to see amounts within that whole, that I can see this whole and there are amounts, quantities that I know the name for and I know the value for. So eventually you're going to get children saying, I saw a 4, a 5, and a 2. Some children, as you work through your fostering of your finding 5s, will see that there are 2 5s and 1 remaining. As you are moving through, at the beginning, you're not going to be representing this in an abstract way. You're going to be encouraging them to get their hands on it, make the patterns, notice what's inside, discussion. As you move through the scope and sequence, you'll be scaffolding them to show how their thinking could be written down in a shortened form in an abstract way. So if they say there are 2 5s and 1 remaining, you might write 5 plus 5 plus 1. As you move through, you may even show them how that could be represented using multiplication. So 5 multiplied twice and 1 remaining plus 1 is 11. The goal isn't to get to the whole, but eventually they will. So eventually they'll work out that there are 11 inside of this. So if you move through the scope and sequence, eventually children will be given their own image and they'll find amounts inside. I like to start with 5s, and I like to start with 5s because 5s are that foundation benchmark number that we really concentrate on to get to our 10. That firm sense of 5, that firm sense of 10 is what's absolutely crucial. So we'll be finding 5s. Now that's accessible for everybody. If you follow my group, you'll notice what children do. They'll go in and they'll circle the fives and they'll record their thinking in an abstract way. So they may say 5 plus 5 plus 1. They might, with the extra challenge, start saying 1 plus 1 plus 1. They will start recording 11 in as many ways as they can. Children that like an extra challenge will move away from the dots. They'll think about 11 and represent it in other ways. Okay, so the entry point for this kind of activity is really accessible for everybody, but is also a challenge for others. And so they will challenge themselves to represent 11 as many times as they can. So even moving away from how it's looking on the page. And so that is your entry point to your multiplicative thinking, finding equal amounts inside of the whole. Once they're really great at finding fives, you will be working on, okay, let's find threes. How many threes are inside? How many twos? What do you notice? I like to use images where there's not going to be always an equal grouping. So we're not always just going to have lovely, neat 3 5s inside of there. There's going to be one remaining, so we can talk about that and how that also could be represented in an abstract way. So those dot talks are not only the building blocks of our addition and our subtraction, but they are also the building blocks of our multiplicative thinking. And they are one activity in the scope and sequence that takes children right the way through. And that's why I love them so much. So rather than saying how many, we're talking about what do we notice? We're talking about the whole. We're talking about the parts inside of that whole to find the whole. So as you're advancing through the scope and sequence, you're going to be looking at large quantities. And so here we have 15 arranged with the wooden patterns. Arranging it with this, we've got the 15. The 15 is our whole. Really easy to say to children, how many fives inside of that whole? Let's take the whole and let's partition it, or let's break it up into its fives. Let's break it down into fives. Find the fives inside of the whole. Now, I like to do that as a reference point here as well. By this time in the scope and sequence, children should have a good understanding of 5 frames and 10 frames. And so it's a nice little scaffold to think about that 5 frame as well when we are pulling apart a whole into equal groupings. Now, again, it's cool to be thinking about when we don't have equal groupings, what is remaining, that kind of thing. So we've got our 15 here. How many fives? Well, I'm sorry, how many threes? How many fives? Because that's really simple, isn't it? How many threes? So initially, we're going to look at how many threes are inside that whole. We've lined it up in a basic 5 frame here. How many threes are inside that whole? I can find 5 threes inside of that whole. I can find 3 5 times. So 3 multiplied 5 times is 15. And 15, if I am finding threes inside of there, I'm going to have 5 groupings of those threes. So you can be exploring it around. Again, we're not assigning abstract recording to this yet. We are exploring and talking about what we notice. So I had my 15. Remember, we looked back on my 15 and what that looked like. And now we've split that 15 up into groups of 3. We've found threes inside of that 15. And how many threes did we find inside of that 15? We found 5 of them. So our 15, looking for threes inside, I found 5 threes. I can see now that that would be easy to show them how we can represent that abstractly. Now, my children, through the scope and sequence, I teach them 3 multiplied 5 times. Yes, we can do 5 groups of 3. Means the same thing, and that's fine. However, in the image before, we could see the 5 multiplied 3 times. And so that linking and understanding, I like to use multiplied, so 3 multiplied 5 times. I found that when I started phrasing it in that way and explaining it in that way, my children that struggled to move on with their multiplicative thinking to represent it understood it. When I talked about groups, they found that quite difficult. It doesn't matter to me how you choose to do this, but this is the way I do it because I found that children's understanding really deepened. Okay. So if we look at 12, so we've represented 12, we can see the whole 10 and the 2 more. And we're thinking in here, okay, 12, let's find the 3's inside of 12. So take the whole 12 and we want to find 3's inside of here. Okay, so if we've taken the 12 and we find 3's inside of there, we can see that top that we've got 4 3's. 3 has been multiplied 4 times and there are 4 3's inside of 12. And we can compare it to what we were doing with 15. What do you notice? And so there you're incorporating that thinking about what do you notice. Again, you can be teacher modeling how this could be represented in an abstract way, but it's not really the point yet. The point is to encourage that multiplicative thinking, to take the whole, to find those equal groupings, to notice, to compare. So we talked about 15, we talked about 12. What do you notice about the 3's inside of 15? What do you notice about the 3's inside of 12? What can you tell me about that? And then if we move backwards, we're looking at 9. So the whole 9, we can see the 5 and the 4. That 4 should technically be yellow. But anyway, we've got the 5 and the 4. And if we look again, we squash them all onto the screen, which isn't ideal because it looks a little bit confusing, but we can see how many 3's did we find inside of 9? We found 3 3's inside of 9. Okay, so what do we notice when we compare that to the 12? What do we notice when we compare it to the 15? And again, we can be showing children how to represent all of this in an abstract way. We can show them how it would be represented in multiplication. If we're looking at this, we're saying 3 multiplied 3 times. We can show them 3 multiplied 3 times is the same as 9. We can put it back together. We can pull the 9 apart into 3. 9 divided into into 3's is 3. We've got 3 groups, so we've divided it into 3's. We've found 3's inside of 9. We can show them how it's written down. I don't expect them to be writing that in an abstract way, but we can certainly show them. Now, when we're doing this, obviously children are also going to have their own counters and they're going to be representing this. They might like to represent it visually as well. I like to use the 5 and the 10 frames in this way, just because children know a 5 frame deeply, they know a 10 frame deeply. It helps them to see the groups really quickly and how many times that 3 has been found inside of that amount. Yeah, so that's how the scope and sequence encourages you to children to explore multiplicative thinking. You can see how it's linked to the notice, how you can be linking it to the noticing, how when you're working, you can be explicitly sharing how it is working. But it would be really cool here to throw in an example. Okay, we've got 10. How many 3's inside of 10? Right, we've got 16. How many 3's inside of 16? And we can be thinking about that as well. What I find is that children that have a really good basis knowledge of this and like that little challenge, they enjoy representing this in an abstract way, and that is fine. Children not quite ready for that, that's fine too. So this way of working has a great entry point, but also a great challenge point for children. Okay, so hope that is useful. Really, the main point is with the wooden patterns, when we're exploring multiplicative thinking, we are taking it from that whole and we are finding amounts within that whole. We're not always finding equal groupings. We are looking at remainders as well. It all bridges from the dot talks, which are really vital in terms of noticing and wondering and developing that early thinking. What I find is because we're doing the dot talks because we're breaking wholes into parts and we're finding those equal parts. We're not explicitly saying this is multiplication, this isn't times tables and division. We're not explicitly saying that for a little bit. Okay, these skills, we're looking for amounts inside the whole. I don't refer to them as multiplication and division. A lot further on, we're developing the foundations of those skills really early, but it's not something we are technically referring to or writing in an abstract way until children are really ready for that. What I find is through the dot talks, children start to represent their thinking for multiplication. If you look at some of my group posts, you will see that some do, some don't, and that is okay. And so we're building that understanding. Now, that was a really quick little slideshow. I hope it gives you some idea of how we're looking for that whole, pulling apart the parts and finding those groups within the whole, starting with fives and working from there. And we can be building, if we were working on threes, then we can work on fours, and we can work on, and we can develop our understanding of multiplication and division together, which is how it should develop. Okay. Ka kite.